Good evening, everyone. Can you all hear me?
Yes, ma'am.
Okay, hello, everyone. So, I am Niketa. I'm a PhD student at IIT Madras. And this will be our week one of the live session for the NPTEL course Environmental Quality Monitoring and Analysis. Okay, so what I will do in these live sessions is that I'll give you a brief of the topics that were discussed in the previous week's lectures, and then we will solve some assignment questions. Is that okay?
Okay, ma'am.
Okay, so okay, so since this is the first class, so we will be looking at the basics and we will just start with the general introduction. So, I hope you guys know what is called environment. So can someone tell me what is meant by environment? What is environment?
It refers to the surroundings of human being or
Yeah, so environment is basically anything and everything that surrounds us. So it includes both biotic and abiotic components. So by biotic components, we mean living beings. This includes living beings like plants, animals, etc. And abiotic components will include what? What will come under abiotic components?
the sun.
Sun. Okay, so abiotic components include water, air, soil, basically non-living things. Maybe like as you said, sun. But sun is it's not a part of our direct environment. So like if we consider maybe sun is too far from the earth, so it doesn't come under the category of environment. But basically environment means anything and everything that surrounds us, which includes basic media like water, air and soil, as well as living beings. Okay, so when we have a pollutant in the environment, it can reach us in multiple ways. So these ways or pathways of pollution, so there can be multiple of them. Now, can someone list out what are the different pathways of pollution? What are the different ways in which a pollutant can reach us human beings?
Like by air, water, and
Yeah, air, water, it is there. But how does it reach our body?
respiration.
Sorry?
Respiration.
Yeah, respiration, inhalation mostly. Respiration is like it's a metabolic process where you inhale and exhale. So that is different. So inhalation is one way in which the pollutant can reach our body. That is if it is present in the air. For example, you have pollutants like particulate matter. So by inhalation, these fine particles they enter our nostrils, and from our nostrils they enter into our lungs, and they stay there. So one is inhalation. What is the second one?
Ingestion.
Yeah. And what does ingestion mean?
By oral.
Yeah, orally. So when you have some contaminated water, or maybe crops grown in contaminated soil, which will have the pollutant. So when we drink such water, what happens is that the pollutant will enter into our body through our mouth. So this comes under ingestion. So what is the third one?
By dermal.
Yeah, by dermal contact. So this is through the skin. So when we have some contaminated soil, or we touch some contaminated soil, or people who are working in mines, when they work in such places, so sometimes like some components could be, some metals can be like there could be some components which are very hazardous. So in such cases, the components can just when we just touch something, so through that the pollutant can enter into our skin. So this is one example of I mean, mining is in mining usually this happens, especially when it comes to asbestos mining. So when people work in such conditions, when they mine asbestos, sometimes the asbestos also enters into our skin, and yeah, there can be many such instances, like people who work in factories or industries where chemicals are produced. So even though we wear masks and we don't ingest them, there could still be some fumes and vapors which can just diffuse through our skin barrier and enter into our bloodstream. So even even when we play, or even when we get into water that is contaminated with heavy metals, even then the pollutant can cross our dermal barrier and enter into our body. So okay, so we have seen how pollutants can reach us. So now we'll talk about classification of pollutants. So how can we classify pollutants? What are the categories?
By organic and inorganic.
Yeah. So this is one of the easiest ways in which we can classify the pollutants. So when we say something is organic, what does it mean?
Consisting of carbon chains and
Yeah, something which has like a carbon hydrogen bond. So that is organic. And inorganic is like, can you give me some examples of inorganic pollutants?
lead can be
Yeah, lead, basically heavy metals. Any other examples?
tin can be example. Achha, okay.
Yeah, I think.
Mercury.
Sorry? Yeah, that also comes under heavy metals. So other than metals, can you think of something?
Chlorine, chlorides.
Chlorine, no, I don't think chlorine is like, chloride cannot be called as a pollutant because we need some quantity of chloride in water. But yeah, there can definitely be suspended solids. Now again, suspended solids can be both organic and inorganic. So sometimes it can be it can be both organic and inorganic. So again, the next classification is based on application. So application is like, so when we use something, for example, we use some disinfectant. So from that, the chemicals can leach and it can enter the water body. So that is one example. Can you give me some more examples?
Pesticides and fungicides.
Yeah, pesticides. Usually, when there are agricultural lands nearby, so the pesticides that are used in the agricultural land, usually when we water these plants, so the water will just drain through the soil from the plants, and then it will flow through the nearest water body where it will get collected. So along with the water, the pesticides also enter the water stream. Okay, then there could be like pharmaceuticals. Actually, this list is exhaustive. So there are many instances where when we use something, it pollutes the environment. So when we talk about analysis, so what is analysis basically?
By analyzing the health impacts and finding the source.
No, I'm asking like what is the meaning of analysis? What do we mean when we say we have to analyze?
Describing the pollutants.
Describing the pollutant through what? How will you describe? So you know you have a pollutant, but how will you decide, or how will you determine what it is?
By the effect.
Assessing the quantity,
Sorry?
quantity of the waste.
Quantity, yeah, but
The concentration of that pollutant.
sorry.
The concentration of that pollutant.
Yeah, so the concentration, yeah, that is, yeah. So when we say analysis, what we mean is conducting a series of tests. Okay. So the method of analysis can be of two types. One is the qualitative, and the second one is quantitative. So someone said concentration, so this will come under the quantitative category. So initially in the preliminary stages, when we have a water pollutant, we won't directly go and test how much BOD or COD is there. First, we have to screen it. So screening means preliminary analysis. So it involves checking for the color, the turbidity, odor, and taste. So all these can be determined by physical methods. Like we can just observe if something is colored, or if the water is turbid, or if there is just smell coming out of the water sample. So all this can be just observed by the naked eye or by using our nose. And so this is the first step. So once this is done, we will go for the further analysis. So when we say turbidity or color, it can be caused by, when we say color, it can be caused by total dissolved solids. So what are total dissolved solids? These are just like someone said, chloride or some salts which are dissolved in the water sample, which will give some color. And turbidity is caused by total suspended solids. Now these solids do not dissolve, instead they just remain suspended in the water, and they don't settle down. So they just remain floating in the water, not floating, they just remain suspended in the water. So, because of that, light will not be able to pass through the water sample. So, that gives rise to turbidity. So, together, these two form the two types of solids that are generally found in water. So now coming to air. So similar to suspended solids, we also have solids in air, and in air these are called particulate matter. Okay, so can someone tell me what are the two types of particulate matter generally known, very commonly used?
PM10 and PM2.5.
Yeah. So PM10 means that the aerodynamic diameter of the particle is less than 10 microns, and likewise PM2.5 means that the aerodynamic diameter of the particle is less than 2.5 microns. Okay, so particulate matter is just these solids which are floating in air. But other than that, we also have criteria pollutant list. So this will include gases like NOx, SO2, ozone, carbon monoxide, which also includes PM, and sometimes even unburnt hydrocarbons. Okay, so there are numerous ways in which we can control these pollutants. So the first and the most easiest method to control is at the source. So can someone tell me what do we mean by source control?
I'm controlling the emission of that pollutant.
Yeah, so controlling the
it is controlling the emission at the source. So, which
yeah,
means
it
that
is
if there is
controlling
any
the
industry
emission
which is
at the
generating
source. So which means that if there is any industry which is generating pollution,
easiest way
so
to
the
avoid the pollutant from
easiest way
spreading
to
is
avoid
just
the
control
pollutant from
the
spreading is
pollutant at
to
the
just
site
control
where it is
the
being
pollutant
emitted.
at the
So, if
site
it is an
where
industrial
it is
emission,
being
then
emitted.
just
So if
if
it
it's
is an
coming from a
industrial
stack,
emission, then just
then
if it is
just
coming from a stack,
control the
then just control
install
the
some pollution control
install
devices
some
to
pollution control
ensure that
devices
the
to
pollutant does
ensure
not
that
escape
the
out from the
pollutant
stack.
does not escape out from the stack.
So why is it the
So
easiest
why is it
method?
the easiest method?
Because there's no after effect of that pollution.
Uh, Actually, what happens is that once the pollutant is released into the air, it's very difficult to control its movement. So it depends on many factors. Like sometimes it depends on the temperature, it depends on the atmospheric conditions. There are so many factors which can influence its movement. So when we still have the pollutant which is inside the stack, or when it is inside the stack, or it is just being produced from a small place inside the factory or industry, it becomes easier to control it. So that is why source control is very important. And if we are unable to control it at the source, then we go for the second most easiest option, which is in the ambient environment. So this means that your pollutant is out in the air, and we have to find ways to control it somehow. And the third way is one of the most difficult ways. So, at the point of receptors. At the point of reception. So, this means like if we, for humans, humans are mostly, we are the receptors in most cases. So, at the point of reception, we can wear masks. Like during COVID, many of you would have worn the N95 masks. So that is a way of preventing the pollution at the site of the receptor. So wearing masks is one way. Wearing earmuffs to protect ourselves from noise pollution. So all this can be done, but it's always best to control pollutants at the source. Okay. So the next topic is sustainability. So can you tell me what is sustainability? What do we mean when we say something is sustainable?
To control the pollution in such a manner that environmental, economical, and social demands meets each other.
Okay, but you are talking about the components of sustainability. I'm asking what is sustainability? What do we, I mean, what comes to your mind when you think of sustainability? Ability to maintain what? Viable or acceptable? Okay, why should we have viable? Why should it be viable or acceptable? Exactly. So preserve the environment. So it basically sustainability means using the resources in such a way that we as well as our future generations are able to use those resources. So it means it basically means not overusing the resources that are available. So that is sustainability. And like someone said, there are three components of sustainability. First one is environment. The second one is the society. And the third one is economy. So when we say something is a sustainable solution, it should be environment friendly. It should not harm the environment. It should not harm the society in any way. It should be safe for all kinds of people, of all societies, communities. and it should also not harm the economy in any way. Something which is not very expensive, something which is cost effective. So, when we design something to control pollution, it should meet all these three components. It should be environment friendly. It should be acceptable by the society, as well as it should be economically viable. Okay, so coming back to particulate matter. So, like one of you said, there are two types, most prominent types, PM10 and PM2.5. So, like I already said, PM10 means particles whose size is less than 10 microns, whose aerodynamic diameter is less than 10 microns. So, can someone tell me what is meant by aerodynamic diameter? What is
The diameter of an equivalent particle of 1 gram per cc that has the same Stokes settling velocity.
Yeah, so in this definition, is everything clear for you?
Yes, ma'am.
Okay, so what is settling velocity?
The velocity that a particle can when fall through a fluid versus the drag, the friction or buoyancy it experiences.
Yeah, so it's basically the velocity of the particle under equilibrium. So when we have a particle in a fluid, so it will have two forces acting in opposite directions. One is the gravitational force, the other one is the buoyant force. So these two will drag the particles, and because of which the particle's initial velocity will be high, but after attaining equilibrium, it will follow a steady velocity. That means it will follow a constant velocity. Initially, it will have a varying velocity as soon as it is dropped inside, but finally, after reaching equilibrium, it becomes constant. So why does that happen? It's because these two opposing forces will be equal to each other, and there will be an equilibrium. So in that case, in that case, whatever the velocity of the particle is there, that is your settling velocity. So this settling velocity is very useful for designing wastewater treatment systems when we have components like sedimentation tanks. It becomes so it is important to know the settling velocity of the particles to design sedimentation tanks. Since most of you are chemical engineers, you may not be aware of this. Okay. So this is valid for all fluids. It's not just liquids. It's not just water. It can also be in the case of air. So yeah. So when we have particulate matter, so how do we control particulate matter? Suppose you have an industry which is emitting a lot of particulate matter. What will you do to control it? Okay, so let me give you an easier example. So you have a lot of solids in water. Gravity settlers, gravity settlers is one option. So that's a good answer. So if you have you have a there is a lot of muddy water. Okay, how do you remove the particles of mud from water? What is the simplest way in which you can do it?
By by filtrating
Yeah.
about the particle size.
Yeah. So similarly, when we have particulate matter in air, we can use filters or fabric filters. So fabric filters will have small pores. So imagine these are the threads of the fabric. So you have pores here. So in case the particle diameter is bigger than the pore, then it gets stuck between the two threads. So in that way, you can stop the particle from moving forward. So when we have this mechanism of filtration, so it is important that the particle comes and gets stuck on the pore, or it should get stuck on the fabric. Like somehow it should just stop, or it should stop moving. So there are many ways in which the particles can deposit on the filter. So the first way is by inertial impaction. So what is inertia?
Tendency to remain in a position or in a constant velocity.
Yeah, it is a state in which something which is in a state of motion will tend to be in that state of motion, and which is in a state of rest will continue to be in the state of rest. So that is inertia. So when we have a moving particle and you have an obstacle here, so the particle keeps moving and it doesn't have much time to change the direction. So it just keeps moving in the same direction and it gets impacted here on the obstacle. So that is one way in which the particle or the pollutant can get deposited on the filter. Second way is by interception. So can someone explain what is this? Yeah, Piali, you had something to say?
No, ma'am, not right now.
Okay. Any answers? What is interception?
Creating a barrier.
Yeah, like stopping something midway. So here what happens is that the particle, even though it doesn't want to hit the obstacle, the wind will force it. So it gets stuck on the obstacle. So the third way is by gravitational settling. Now this happens due to the particle weight. So sometimes the particles which are floating from above, they just, because of their weight, they tend to move towards the obstacle which is slightly downwards, because of the force of gravity which is acting on them. Fourth one is the Brownian motion. So what is Brownian motion?
The randomness motion of the particle.
Yeah, so it happens like there is an obstacle and there is a particle. So randomly it just tends to move and comes to the obstacle. So because of no external forces, just random movement, so which affects the, which makes the particle move closer to the obstacle. Third one, last one is the electrostatic attraction. So why does this happen? Why is there electrostatic attraction?
When the particle holds charge.
Sorry?
When the particle is charged.
Yeah. So generally all particles will have something called a surface charge. So if the surface charge of a particle is negative, so on the surface it's all electrons and it is negatively charged. And if the obstacle here is positively charged, so it could get attracted to this and it could come and settle on the surface. Okay, so these are the different ways in which the particles can deposit on the filter. Okay, so do you have any questions from this week's lectures? Any questions or doubts? Any clarification?
These methods of particle deposition is applicable for aerosols, right?
Yeah.
So when aerosol act as a cloud condensation nuclei.
Sorry?
So when aerosol act as CCN, cloud condensation nuclei.
Okay.
The water vapor deposits on that aerosol particles. So is all of the process is there to hold that CCN, or like only that interception and electrostatic interaction?
In case of CCN, the mechanism will be slightly different because your particle size will keep on varying. Right?
Okay.
So in that case, like the inertial impaction will not, there could still be some inertial impaction, but the direction of the particle motion will change. So it won't be the same. So in that case, mostly it will settle or it will deposit due to gravitational settling.
Okay.
Any other questions?
No, ma'am.
Others?
No, ma'am, it's okay.
Okay. Okay, so now we will solve the assignment problems. Have you all completed the first assignment?
Yes, ma'am.
All of you have submitted?
No, ma'am, I haven't submitted right now, but I have gone through the questions.
Okay. So does anyone have any difficulty solving the assignment? Is anyone facing any difficulty in solving the assignment problem?
No, ma'am.
No, ma'am. The week one assignments
Sorry?
are easy.
Yeah, week one assignments are easy, but we'll just discuss them, some of them. so that even your concepts will be clear. So the first question is, in the scheme of pollutants, and environmental quality, so the question is, in the scheme of pollutants and environmental quality, which is the most appropriate sequence of the pathway of pollutants? So the given options are, first one, exposure, freight and transport, and then source. Second option is freight and transport, and then exposure, and then source. Third option is exposure, source, and freight and transport. So the last option is source, freight and transport, and then exposure. Okay, so which is the correct answer? Piyali, can you please, like, if you have something to say, otherwise, just can you please mute your speaker?
No, ma'am. Could you please explain the sequence of pollutant pathway?
Yeah,
Option 4 is
yeah, Piyali, you want me to explain the pathway?
Yes, sequence of the pollutant pathway.
Okay, sure. So, can you please mute yourself?
Okay.
Thank you. Okay, so as we just discussed in the beginning of this class, so how does a pollutant travel? So if there is a pollutant, there should always be a source from which the pollutant is coming. So this could be some industry, or it could be some agricultural land from where pesticides and insecticides are coming and mixing with water. It could be just vehicles on the road, or it could be some chimney at home. So all of these are some examples of sources from where pollutants can come and mix in the environment. Okay. So if there is a pollutant, there is always there is a source. So once the pollutant has come out of the source and it has reached the environment, what happens is usually we have two kinds of media. One is air, the other one is water. So both of these are like air is also, wind is also a fluid, so is water. So what happens is that the pollutant, as soon as it comes into, it is released into the air or it is released into the water, it tends to move. So it tends to get transported from one place to another place. And also, once it starts moving, we don't know where it will end up. Okay, so that is called the fate of the pollutant. So the fate means like what happens to the pollutant. Once it is released into the environment. So this is the fate of the pollutant. So what happens to it? How can we determine what happens to it? Any answers? Okay, let me give you an example. So suppose you have a forest fire. Okay, so you have a forest fire in somewhere in the eastern part of the country, and the wind is moving from east to west. Imagine. So, and you are able to detect the pollutant, which is the particulate matter, the gases, CO2, SOx, NOx, everything, in the western part also. Okay, so that's how you come to know that the pollutant is traveling from east to west. But you still don't know what, what pathway it is following, right? Where and all it is going before it reaches the west side. So for that, you need to have monitoring stations. So if you have monitoring stations, you can monitor the pollutant in different places along its pathway, so that you can be sure that this is the pathway that the pollutant is taking. Okay. So when it comes to fate and transport, so transport is the movement of the particle from one place to another place, and fate is how it transports, like what pathway it follows, what direction it follows, and ultimately where it is going to end up. So all this will come under the category of fate. So when we generally have a pollutant which is being released into the environment, it is absolutely necessary to monitor it and determine the fate and transport of the pollutant, because sometimes we don't know, like there could be some someone okay. So if we the water that we drink, it could be contaminated with let's say antibiotics or something, but there is no antibiotic producing factory nearby in the next 10-kilometer radius. So how can if antibiotics are detected in my drinking water, then how can I don't have any idea, right, how it is ending up in my drinking water. Like for me, I'll just see that okay, in the next 10-kilometer radius there is no antibiotics producing factory. So in that case, we need to monitor from where this water is coming from and what are the different industries that are dumping their wastes into this water source, right? So that's how we have to do this transport and fate. Like we have to when we have a water source, or when we have like uh, a river or a lake or something, we need to see, and if something is detected in that river or lake, we need to see from where it is coming, what is the source. So there could be some factory which is thousands of miles away, and it is dumping its waste somewhere, and that river is flowing from that place, and it is reaching my home. So this is the pathway, right? So determining this pathway is essential to control the pollution. And once, so after fate and transport comes exposure. What is exposure?
When the receptor is exposed to the pollutant.
Yeah, so after fate and transport, once the particles have been transported, it reaches some place. Like I just said, if my drinking water is having antibiotics, then my home is the point of exposure, and I am the receptor because I am drinking that water, so it is ultimately coming to me. So that is exposure, getting exposed to the pollutant. Piali, is that clear, or do you have any more questions?
Yes, ma'am. Thank you.
Okay, thank you. Okay, so in this case, the correct option is the fourth one. So this is the sequence in which the pollutant will travel. Coming to the next question. So, which of the following is true about the pathway of pollutants in the environment? The first option is exposure.
Will be option D.
Sorry. So the
The
options
second
are,
question
yeah.
answer would be the option 4.
Okay, let's come to that. So exposure
Yes.
means the movement of pollutants in the environmental compartments. So and the second option is fate and transport. This means mechanism of release of pollutants from a process or device. Source and the last option is okay. Okay, like Piali said, the correct option is the fourth one, because, like we already discussed in this question, the correct which of the following is correct. So about the pathway, obviously exposure doesn't mean the movement of pollutants, and fate and transport doesn't mean the release of pollutant, and of course source doesn't mean the location where the pollution is received, That is the point of reception or exposure. So source, fate and transport, and exposure, it is the correct sequence. So this is the correct option. Okay, and the next question is, which of the following which of the following factors are expected to directly influence the health effects in a receptor of a particular pollutant? First one is toxicology. Second is exposure of the chemical. The third one is the pollutant concentration. And the options are only the first, only the second, only the third, or maybe 1 and 2. Two and 3, 1 and 3, or 1, 2 and 3. Okay. So what is the correct answer?
The last one.
Yeah. So before we go to that, what is toxicology?
It defines the toxic effects and the
Basically,
extent of toxic effects.
extent. Basically, toxicology means studying the effect of a toxin that can have on a human body or on a different animal and all. So this is toxicology. It is basically studying the toxic effect of a toxin. Effect of a toxin. So why this is important? Because you can have maybe let's say you have in pure water you are mixing glucose. Okay, so glucose is also a pollutant, by the way, because it's making the water impure. But what happens is, if you drink glucose, it is not going to cause any harmful effect in your body, provided you are a healthy person. So it is not going to affect you in any way. So in that case, even though the pollutant is there, it is not having much of an effect in the human body. At the same time, if we compare glucose with something like mercury, even a small quantity can trigger a lot of health issues. It can maybe stop your liver from functioning. So in that case, toxicology matters. So toxicology is basically how the pollutant will behave once it enters your body. So if we have a pollutant which is not going to have as much of an effect, on your body, then it is not necessary to study its effects. So, is that correct? Or is it, have you all understood what I said?
Yes, ma'am.
Yes.
Yeah. So, secondly, exposure also matters because, like, how you get exposed also matters. So, one of the, if you have even a little bit of pollutant, and like, let's say you have something which is soluble in only soluble in water, which is a pollutant which is only soluble in water, and you just pass by that river which is contaminated, and you are inhaling the air around it. Okay, will anything happen to you? Imagine you're passing next to a river which is contaminated with pollutant which is only soluble in water. It is not going to be volatile, it is not going to mix into the air. So it's just in that water in a dissolved state. How is it going to affect you when you are passing by?
No, it won't affect.
Yeah, so we are not exposed to it. So our we are not directly exposed to it. So we are not going inside the water. We are not entering the water. So that is why it is not. I mean, we are not going to be exposed to it. So that in that way, exposure also matters. So and also how much we are getting exposed to it. Like someone could just enter the water and then come out, or someone could be in that water, swim for some time, and then come. So even the extent of exposure also matters. So if someone is being inside the water body for a longer time, getting exposed to it every day, going for a swim in that same river every day, then there are high chances that there will be dermal exposure, and the pollutant could enter into the bloodstream, and it could be like it could cause some health effect. So the extent of exposure is also going to matter. And the next one is the concentration. So if you have the pollutant, and if it is in a very small concentration, it is in no way going to affect us. And if the same pollutant is going to be in a very high concentration, definitely it will have some adverse effect. So all these three things matter. So when we say we are having health effects due to a pollutant, it could be because of exposure, toxicity, as well as the concentration of the pollutant. Next one. So, which of the following is true? With reference to exposure of pollutants to a receptor. The first option is health effects are dependent only on toxicology. The health effects depend only on extent of pollution, extent of exposure. Only the exposure pathway. Okay, so we've already discussed this in the previous question. So, what is the correct answer?
It will
Third
depend on
one.
both.
Yeah. So it depends both on the toxicology and the exposure. Okay. So the next question. Okay, which of the following is not a water quality screening parameter? First option is color. Next one is odor. What is the correct option?
PM10.
Yeah, what is PM10 again?
Option C.
What is PM10?
Particulate matter of radius less than 10 micrometer.
Radius?
Aerodynamic diameter.
Yeah. So, particulate matters are generally found in air. So that is why it is not a water quality screening parameter.
It will be turbidity, ma'am.
I'm sorry. The question is which of the following
Turbidity.
is not a water quality screening parameter? So turbidity is a screening parameter. We can observe it visually. So turbid water generally light cannot pass through. So the particles will, they will just reflect the light, scatter the light in different directions. So the light cannot pass through. So that is why we see turbidity and can be observed visually. So yeah, that is not correct. The correct option is PM10, option C.
Okay, ma'am.
Okay. So the next one is which of the following? I'm sorry, I think this is question number 6. Which of the following is not considered as criteria air pollutants? Options are carbon monoxide, PM 2.5, pH, NOx, and SOx. Okay, can someone tell me what is the correct answer?
pH.
Yeah.
pH.
Why? You were saying, Rakesh, you were saying something?
pH.
Yeah. Can you tell me the reason?
pH is determined for the acidity.
Only for acids.
No, like the acidity and basicity of that
Yeah, of
solution.
what? Yeah. So mostly pH is determined for liquids because we see how much of H plus or OH minus ions are there. So if H plus ions are there. So if your pH is the negative log of
Minus log of H.
H plus ion concentration, So it will tell you if the solution is basic or acidic. So H plus ions cannot exist in air, so that is why it is not pH cannot be determined in air, but it can only be determined in liquids. It is only determined in water or a solution containing water. So that's because the water will dissociate it to H plus and OH minus. So if H plus ions are more, then it is more acidic. If it is less, then it is more basic. So accordingly, your pH will also be vice versa. So if H plus concentrations is high, it is inversely proportional. So if H plus is high, it means your pH is low, acidic. And if H plus concentration is less, your pH is going to be high, which means it is basic. Okay. The next question is, which of the following is not considered as a criteria air pollutant? The options are, I'm just sorry, I have repeated the same question again. So which of the following is not an example of surface water? So this is a very easy one. So what is the correct answer?
Well water.
Yeah.
Well water.
So sources of water can be of two categories: surface and subsurface. So when we say subsurface, it means under the ground. So underground we have structures called aquifers. So aquifers are basically rock formations that can store water. Now again, aquifers can be of different types. We'll come to that in the next we'll come to that later. So basically, aquifers are structures under the ground which are capable of storing water. So whatever groundwater that we get is because of porous aquifers which are able to store the water. So when we drill a bore well, basically we are just drilling through the rock and extracting the water. So since the pressure inside the rock is high, so as soon as we drill the bore well, the water will rise up because the pressure here is high and here it is low. It is getting exposed to atmospheric pressure. So atmospheric pressure is lower than the pressure inside the rock. So that is why it immediately rises up and comes to a certain height. Okay, next question. Which of the following is true? With reference to the classification of chemicals of environmental concern. So chemicals are classified only on the basis of chemical structure and on the basis of chemical structure, applications, and their physical state. Third option, the organic chemicals are of concern. Okay, so what is the correct option?
Option 2.
Yeah,
The
So-
second option.
yeah. So we cannot classify only based on the chemical structure. We also need to see where they are applied and what is their physical state, etc. And also we need to determine if they are organic or inorganic. So we cannot say that only inorganic or only organic chemicals are of concern. So that is why the second option is the correct one. Next one. So which of the following are pathways for environmental exposure? So inhalation only, inhalation and ingestion, inhalation, ingestion, and dermal contact. So what is the correct answer?
Third.
Yeah. So all the three, inhalation, ingestion, and skin contact, are pathways of environmental exposure. So next question. Which of the following which of the following is an example of an environmental receptor? First option is humans. Second is plants and animals. Third option is buildings. Fourth option is all of these.
All of these.
Yeah. Why? Can someone tell me why?
No, how come building is an example of environmental receptor?
Yeah. So, do you know about the pollution? How pollution affected Taj Mahal?
The acid rain phenomena.
Yeah. So that is an example where a building, which is a non-living thing, is a receptor. So it is receiving the pollutant and it is having some effect of that, right? So the color of the marbles changed from white to brown. So that is an example where buildings can also be affected. Even our very own residential buildings can also be affected by pollution. So when we have a drilling or when we have some demolition activity going on, the dust can come and settle on the building walls. Or if we are staying close to seaside, there could be chances of mold growing on walls, right? So all these are examples where the buildings become environmental receptors. Okay, so the next question. Which of the following terms describes the behavior of a chemical from its source to its receptor? That behavior of a chemical from its source to its receptor. Okay. So the first option is emission control. Exposure control. Freight and transport. Remediation. Toxicology. So what is the answer?
Freight and transport.
Yeah. So freight and transport is what will determine how a pollutant will start from a source and reach its receptor. Yeah, you had something to say?
It will be freight and transport, ma'am.
Yeah, that's the correct answer. Second one, the 12th one. In the scheme of a pollutant. Okay, so the question is, in the scheme of a pollutant pathway, which of the following is an example of emission control? First one is catalytic converters. Second one, cleanup of contaminated soil. Wearing a mask. Taking medicines. Okay, so what is the correct option here?
Option 1.
Option A.
Yeah. So what are catalytic converters? What are catalytic converters? Why are they used?
To control the exhaust emission.
Yeah. And how does it convert? I mean, how does it control? Any answers?
To burn that unburnt hydrocarbons.
Yeah, so basically they combine oxygen with carbon monoxide and unburnt hydrocarbons. Sometimes they also reduce the NOx gases. So in this way, instead of NOx, maybe you will just get nitrogen. So, and these are mostly used in the exhaust pipe of cars to prevent these gases from escaping. So, cleanup of contaminated soil. This is an example of what? Does it come under pollution control?
This is a remediation.
Yeah. So it is an example of where the pollutant is controlled in the ambient environment. So once the exposure, once the pollutant has been released, it is there in the soil. So we are trying to clean up the soil to prevent the pollutant from escaping into the groundwater and contaminating it. And wearing a mask. So this is also pollution control, but where is it coming? Where does it happen?
During the exposure.
Yeah, so at the site of exposure or at the site of the reception. So receptors, like human beings, we wear a mask. So if you go to Delhi, you have to wear a mask because you are getting exposed to PM10, PM2.5, and that's very harmful. And the last one, taking medicines for allergies. Is it like what category will this come under?
This is after the health impacts.
Yeah, so this does not come under the category of pollution control. So we are not controlling the pollution. So this is taking medication is like after we see the effect of the pollutant on the body, we are taking some action. So this does not come under the category of pollution control. So only the first option is the an example of emission control here. which of the following is an example of exposure control? First option is effluent treatment plant. Second option is remediation of contaminated sediment. Third one is water filtration. Fourth one is catalytic converter. Okay, so which of the following is the correct answer? I mean, which of these is the correct answer?
Water filtration.
Yeah. Why?
Because this is at the point of controlling during exposure of receptors. So,
Yeah, so it is basically done at the point of reception, right? It's done at the site of the receptor. So, effluent treatment plant, what is this?
emission control.
Yeah, so it is done at the site of the source itself. So sometimes industries will have their own effluent treatment plants, so which is used for treating the liquid waste. So before dumping this liquid waste into rivers and soil, it is necessary that they have to treat it first. So that is why they will put it into an effluent treatment plant where it is treated, and the treated water can be sent to the rivers. So this is an example of emission control at the source. The second one is remediation of contaminated sediment. What is a sediment?
The accumulated particles on the base.
Base of what? Accumulated where?
Base of water bodies.
Yeah, so if you have a river or a lake, so the solids at the bottom. So these solids are called as sediments. Sediments can be soil, it can be organic matter, can be humus, can be dead uh, fishes or plants. So all this can constitute sediments. Next question. Which of the following is a component of natural soil? First of all, what is natural soil? Okay, we'll see the options. Sand, silt, organic matter, pore water, and pore air. Yes, Valsa Kumari, you have an answer?
Organic matter, pore water, and pore air.
Okay, so before we go to that, what is natural soil?
Natural soil is formed by the degradation of a rock.
Yes, in a natural process.
It's known as weathering of rock.
Yes. So, what is weathering?
By the action of physical and chemical factor, that a rock first becomes a stone, then small stone, which then finally break down into soil.
So, it could be due to the action of moving water,
Moving water, wind.
etc. So, all this can break down the particles or rocks into smaller particles. So,
Smaller,
finally,
yes.
small enough to be called as soil. And components of natural water natural soil will also include organic matter because it is so organic matter is also a part of natural soil because when we say soil is a combination of various components. So one of them is organic matter because when we have dead plants and animals which just get decomposed and they form a layer of organic matter. So it is also called humus, and it increases the fertility of the soil because it increases the the water holding capacity. So that is why organic matter, pore water, and pore air. So pore water and pore air will exist in natural as well as artificial soil. So organic matter is the correct option. So other components like pore water and pore air are also present in artificial soil. So the right option is C. So silt is like it is also formed artificially. Like when we continuously mill soil and make it into finer and finer particles, we get silt. And these days we have M sand, which is produced artificially. So unlike river sand, which is produced by erosion, so these days it is very expensive to get river sand. So people have started cutting rocks and grinding them to make sand. Next question. So unsaturated zone in soil is also known as Endose zone, Vadose zone. Okay, so which is the correct answer?
Vadose.
Yeah. So aquifer is basically a structure which is present under the ground, which is porous and it can hold water. So there are different types of aquifers, and some aquifers will be completely filled with water. It will be saturated, and in some cases it will be unsaturated. So what do we mean by unsaturated? So suppose you have an aquifer and there is some empty space which is occupied by air and the rest is occupied by water. So this structure becomes unsaturated because it is not completely saturated with water. The pores are not completely saturated with water, so it becomes unsaturated. So compared to a saturated zone, an unsaturated zone will behave differently because there are two states of matter existing in this, air and water. So that is why the pressure could also be different, and the mechanism of pollutant movement is also slightly different when we compare a saturated zone with an unsaturated zone. Okay, so the next question is, match the following. So first one is color. Okay. The options are So what is the correct option?
Option 4.
Okay.
4.
Yeah. So before we go to those options, so we'll first discuss these terms.
So what are
VOCs?
Volatile organic compound.
Yeah.
volatiles
So
for
volatiles
short.
for short.
And
And
so when something is volatile,
so when something is volatile, it tends to evaporate quickly. And when we have organic compounds that are volatile, when they evaporate, they release some kind of smell. Like, for example, you have petrol. So when you have like
vessel carrying
vessel carrying some oil in this. So they when these vessels break down. Did you have something to say?
If you didn't have something to say, can you please mute?
Okay, if you didn't have something to say, can you please mute? Thank you.
Yeah. So when we have oil spills,
So when we have oil spills where the vessels carrying these petrols and other
oils, they get
oil, they get broken down into the sea and release oil. So these oils are sometimes volatile and they evaporate. So when they tend to evaporate, they generate some kind of odor.
So this is just one
So this is just one example. So there could be soluble organics also, which will dissolve in water and create some kind of odor.
Mostly organics are
mostly they are just volatiles.
sorry, they are not.
I'm sorry, they are not.
Have
I mean, they have some kind of a smell. So when there are volatile organics, so there will be definitely some kind of smell coming out from the water.
Second one is
TDS or total dissolved solids. So these are just salts or any minerals which remain dissolved in the water. So third one is TSS or total suspended solids. So these are solids which are not dissolved. So they cannot be dissolved, so they remain suspended. They are somewhat bigger and they scatter light. So they are known to cause turbidity. Then PM10, we just saw what it means. And so from this, can you tell me which can cause color? Which of these can cause color?
Dissolved salt.
Dissolved solid.
Yeah, TDS, because there could be some heavy metals which remain dissolved, like chromium or maybe some other chemical, which will give a chromium will generally give a yellowish color. So if there are dissolved chromium salts in water, then it will produce color. So this TDS is what gives rise to color. So 1B. And then coming to odor. So like I already said, odor is caused by volatile organic compounds, and then coming to taste. What contributes to taste?
Again, dissolved solid. Taste.
Yeah. Yes.
Dissolved solids.
Yeah. So sometimes water can taste slightly bitter. Could be due to some salts that are dissolved, some minerals which are in excess. So they can cause slight bitterness in water. So taste is again contributed by dissolved solids. So and then turbidity, like we already saw, it is caused by suspended solids. So the correct option is 4, 1B, 2A, 3B and 4C. Which of the following is an accurate description of the term aerosol? The first option is dispersion of gas in liquid. Second option, liquid in gas. Third option, solid in gas. Fourth option, solid and liquid in gas. So, which is the correct option?
Solid and liquid in gas.
Yeah. So, aerosol, so it's made of two words, air and solids. So, air, as you know, air is the medium, and sol can be anything which is a solid or a liquid. So, we can even have aerosol, which is liquid particles floating in air. So, the correct option is option 4.
What is the correct option for question 17?
Yeah, I'm coming to that.
17 you missed. Yeah.
So Again, it's a match. Water quality and function. First is TSS. TOC. Okay, so we've already seen what is TSS, TDS. So what is TOC?
Total organic composition.
Total organic carbon.
Yeah. So total organic carbon. So what is BOD?
Biological oxygen demand.
Biological.
Oxygen demand.
Are you sure the term is biological?
Or biochemical, we can say.
Yeah. So it is the biochemical oxygen demand. So do you know what these terms mean? What is the difference between these terms in your view? Why do we use these terms?
Water quality parameter.
Yeah, these are water quality parameter to measure what?
Qual- Which one? BOD, isn't it? BOD?
TOC and BOD.
Biodegradable organic compound and a total. BOD is a amount of oxygen required to oxidize only biodegradable organic compound.
So what oxidizes? How does the oxidation take place?
In presence of air,
And
microorganism.
exactly. So when we say biochemical oxygen demand, or or BOD in short. So here we measure how much oxygen is required for the bacteria. One second. Yeah. So it is the oxygen required for the bacteria to oxidize or digest. So what happens is that when we have some organic wastes, the bacteria will feed on them. So the waste gets oxidized in the process. So we need to supply sufficient oxygen for the bacteria to live. So the bacteria will tend to eat on the bacteria will tend to eat on the waste and thereby degrading it. And biochemical oxygen demand is the demand of oxygen by the bacteria to degrade the waste. And there is also one more term called chemical oxygen demand. So the difference between these two is that here in BOD we are taking how much oxygen is required by the bacteria to degrade, but when it comes to COD, it is the amount of oxygen required to degrade the waste chemically. So can someone tell me which process will be more efficient, chemical or by using bacteria?
Chemical.
Yeah, so which
will be higher.
will be higher?
Chemical, COD.
Yeah, others?
Because it oxidizes all the organic compound present in water, whether it is biodegradable or non-biodegradable.
Yeah, so others, are you all following?
Yes, ma'am.
Yeah.
Yes.
Yes.
So what she was saying is that chemical oxygen demand means the oxygen required chemically to oxidize the waste. So since it is a chemical process, its efficiency is going to be slightly higher than a biological process. So that is why COD is always going to be higher than BOD. Okay. Now, what is total organic carbon? So this means the amount of the entirety of organic chemicals which are present in a given sample of water is TOC. So these organic I mean this is totally how much of organic carbon is present in your water sample. So some of it can be degraded by bacteria, some of it can be degraded by the chemicals, and some of it may not be degraded by both. Okay, so TOC will include carbons, organic carbon, which are not chemically degradable, which are also not biologically degradable. So in that case, your TOC is going to be much higher than your COD or your BOD, because it is the measure of the total organic carbon which is present in your sample. And we measure this using a TOC analyzer where the organic carbon is converted into CO2, and then we analyze it using infrared. So we have infrared detectors which can detect the CO2 gas, and whatever organic carbon is there, it will be for sure it will be converted to CO2. So that can be detected. So that will tell you how much organic carbon was there in your water sample. Okay, so coming back to the question. So suspended solids can be caused by suspended solids will give what parameter? I mean, what will it cause?
Turbidity.
Yeah, so it is 1A, and TOC is caused by
Organic load.
yeah. So as we
Organic and
how does it include inorganic? No, usually TOC will only include the organic carbon. It does not include anything inorganic.
Okay.
So whatever organic carbon is there, only that will be measured in this test. So TOC will also come, it will also be how much TOC is there in water sample is directly proportional to how much organic load is there. And then TDS, so it is 1A and 2B. So then TDS or total dissolved solids, what can it cause?
Salinity.
Yeah. So sometimes when salts concentrations are higher, it can cause salinity. So 3C. And again, last one, BOD.
Organic load.
Yeah. So it is 4B. So this means it is option C or the third option. Okay. So next question. Which of the following are components of air? First option is particulate matter. Second is gas. Third is vapor. Fourth is gas and vapor. PM, gas and vapor. Last option is none of these. Okay, so which is the correct answer? Someone has said
PM.
option 5.
PM
Yeah,
gas
what
and
is
vapor.
it? Option 5?
PM gas and vapor.
Okay, but when we talk about natural air, it does not have any PM.
Yeah.
Gas and vapor only.
Yeah. So the correct option is gas and vapor. So when you say PM gas and vapor, then it is a polluted air.
Yeah, polluted.
So the correct answer is option 4. Okay, so which of the following are the 3 arms of sustainability? So we already discussed this today in the class. So what is the correct option?
Society, economics, and environment.
And environment.
Yeah, so
Third option.
the answer is society, economy, and environment.
Environment.
Okay, so with this, we have come to the end of this lecture or end of this session. So if you have any questions, please let me know. If there are no questions, then we can end the session.
No, ma'am.
Thank you, ma'am.
Okay. Okay. Thank you all.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.